So this morning we're going to be talking about indirect measurement. And so you can see I have a tree and a wall. I know the height of the wall. I don't know the height of the tree, but I'm going to use the fact that they are form triangles and therefore are similar figures to figure out the missing height that I'm not able to measure. So because they are proportional relationships and they are similar figures, I can use proportions. So you see I have my calculator ready. So you should get your calculator ready too. Here we go. So here I have a wall, and I know the wall is 7.5 meters tall. I don't know the height of my pole, but I need to find that out. Because they are sitting at 90 degrees to the ground, and I can pace off 12 meters here and 60 meters here, I know they form similar triangles. My scale is going to be the 12 and the 60. So because I put the 12 on the top, I have to put the 7.5 on the top. And then I've got my pole right here. So I'm going to take 60 times 7.5, and I'm going to divide it by 12. And so my pole is 37.5 meters tall. Here's one where they are superimposed on each other. So I've got my two triangles. One is formed by the flagpole, and the other is formed by my person. And so the flagpole and the person are corresponding side lengths. And the bottom here is 85 feet, and from the lady here is 10 feet. So that becomes my scale. So I'm going to set that up with 10 and 85. It doesn't matter which one you put on the top or the bottom as long as you're consistent. Because I put the 10 on the top, I have to put the 6 on the top because they come from the same figure. So let's do 85 times 6 divided by 10. And my flagpole is 51 feet. Here's another one that's superimposed. I'm going to get out my blank proportion here. And how deep it is what I'm looking for. But the 10 and the 70 form my scale. So again, it doesn't matter which one you put on the top or the bottom as long as you're consistent. Since the 10 is on the bottom, the 2 has to be on the bottom. And my how deep goes right here. And the label is going to be meters because they're all meters. So let's clear that out. So I have 70 times 2 divided by 10. So it is 14 meters deep. We're just going to keep doing these. So my scale is my 7 and my 14. The 7 is on top, so the 5 has to be on top. So we're going to take 14 times 5 divided by 7. The tree is 10 feet. Whatever measurement whatever measurement you're using is the measurement you're going to get. So because I was using feet, my answer is going to be in feet. This one you have to pay attention to the angles because what happened is these were sitting on top of each other, but then this top triangle swung around. So you can see that this right angle relates to this right angle, which means that this side length relates to this side length. So when you're setting up your proportion, just pay attention to the angles because they're going to kind of tell you what goes where. I already can tell right now. I mean, the side lengths that I know is the 24 and the 6, so they're going to form my scale. So 24 and 6, doesn't matter which one you put on top, but the 8 has to go across from the 6. So 24 times 8 divided by 6. Oops, I need to delete that. So my x is 32, and it's going to be meters. Here's just another one where they're superimposed on each other. So you can see the two triangles. One is formed by the man, the other is formed by the net. So the net and the height of his racket or what are the corresponding side lengths. But if you notice here, this is 6 and this is 12. So together they are 18. So the 6 relates to the 18. The 0.9 has to go across from the 6, and I am looking for the height. Let's clear that off. So I have 18 times 0.9 divided by 6. And the height of the racket is 2.7, and again, it is meters. But I hope everyone sees how I got that 18, right? Because it's 12. This is 12, right? And this is 6. But you need the whole thing. So this whole thing from the net, or from this point right here on the ground to the racket, is 18. Here's another one that's superimposed. So this one, let's do this proportion up here. The two side lengths I know for sure are the 3 and the 6, so they are going to form one side of my triangle, or my proportion. And then I'm looking for this height right here. Since it's in the same figure as the 3, I'm going to put the x. But then I don't know this whole side length, right? I don't know all of this, but I know this part is 4. So this whole side length is going to be x. Whoops, I'm sorry. Still had my eraser on. It's going to be x plus 4. And now I'm still going to do my multiplication, but I'm going to put this in parentheses. So when I multiply this way, I get 6x. And when I multiply this way, I have to do the distributive property. So I have 3x plus 4. So I really have 3x plus 12 equals 6x. So this is just pure algebra at this point. So I'm going to draw my line. I'm going to move my 3x to this side because I want my x's all on the same side. And I'm going to have 12 is equal to 3x. Divide by 3. So my x is 4. So this height right here is 4.